This is the Chapter 11, Unit 4 Test Review, Part 2. So we're on number 14. It says a person who for an hour burns an average of 400 calories with a standard deviation of 10 calories. What is the probability of an hour workout that someone has burned more than 410 calories? Well, in order to find the probability, we're going to need to first draw the normal curve. So in my normal curve, since the average is 400 calories, that's my mean. I'll call it M. And the standard deviation is 10. So one standard deviation away is going to be 410. Oops. 2 standard deviations away is going to be 420. 3 standard deviations away is going to be 430. If I go the other direction, I'm going to be at 390, 380, and 370. Now I need to put in the percents. And again, I'll give them to you so you know what they are. But the middle ones are 34. The second standard deviation away is 13.5. The third standard deviation away is 2.35. And the fourth standard deviation away is 0.15. So the question was, what's the probability in an hour workout that someone has burned more than 410 calories? Well, 410 is here, and here's more than. All I'm going to do is add up those probabilities, 13.5, 2.35, and 0.15. And it turns out that it's 16% chance. Number 15, the scores in the final were normally distributed on the ACT and had an average of 76 with a standard deviation of 4. Out of 75 students, about how many scored 80 or under? So I'm going to draw myself a little curve. The average was 76 and the standard deviation was 4. So if I go one standard deviation away from the mean, maybe I'll use a different color this time for standard deviations away. So one standard deviation away from the mean is going to be 80 on this side and 72 on this side. And a second standard deviation away would be 84 and 68. All right, and so the question was, out of 75 students, how many scored 80 or under? So first we have to find what percent scored under 80. So around the mean, we have, this is 34 and 34, and the next one's going to be 13.5. The next one's going to be 2.35, and then there's another standard deviation over here that's 0.15. So the first thing I'm going to find out is what percent of the people scored under 80. Then once I know that, then I can multiply that percent times the 75 students to find out the exact number of students. So 34 plus 34 plus 13.5 plus 2.35 plus 0.15 is going to be 84%. Or an easier way of doing it is, around the mean, each side is 50%. So that's 50% plus 34 is 84. So 84% of the students. So we're going to multiply 0.84 times 75, and we're going to find out it was 63 students. Number 16. Draw a normal distribution with a mean of 89 and a standard deviation of 9. So this is just a draw the picture. So draw the picture. Here's your mean, and the standard deviation is 9. When you draw this, and the question is always, how many standard deviations should I go out? You should always go out at least 3. So one standard deviation this way is going to be 98. The next one is going to be 107. And the next one is going to be 116. That's 3 standard deviations to the right. Let's go to the left. This one's going to be 80. The next one is going to be 71. And the next one is going to be 62. And that's your standard deviation. Or sorry, that's your normal distribution curve, where the mean is 89 and the standard deviation is 9. Number 17. You have a distribution with a mean of 8 and a standard deviation of 6. What value would decrease the standard deviation the most? Now, I was told this really needs to be a multiple choice question, so I'm going to give you some options. And we want to know which of these values would decrease the standard deviation the most. So your options are 0, 6, 8, 14, and no way to tell. First of all, you should probably cross that off. That's usually not the answer. Well, if you don't have the actual set of data and you can't figure out what number you could plug into the data, recalculate the standard deviation, which one decreased it, we need another way of doing that. Well, it turns out that the number that would decrease the standard deviation the most is going to be 0. And the reason is because it is furthest away from the mean. The further away from the mean a value is, the more it's going to decrease the standard deviation. Number 18 is kind of a generic question because it's a multiple choice question on the test. It says, what can you tell from back-to-back box plots? Box plots are the same thing as box and whisker displays. So when you have back-to-back box plots, some of the things you can tell are which one has the higher median. You can tell which one has the bigger range. You can tell which one has the bigger interquartile range. Remember, the interquartile range is the difference between quartile 1 and quartile 3. Well, clearly the bottom one has a bigger interquartile range. The top one just has a bigger range. That's the difference between the minimum and maximum. The top one has the bigger median because the median, which is the center line in the box, is at a higher numerical value. So those are the sorts of things you can tell from back-to-back box plots. Some of the problems we do not necessarily have one right answer. What I'm going to be grading you on is how you explain your answer. So in number 19, it says you'd like to perform a survey on how the food in the cafeteria tastes. You choose to ask everyone and use this as your sample. What type of sampling model is this? Explain whether this is a good or poor way to conduct a sample. Now, the reality is you actually can't ask everyone, so I have a sneaking suspicion that this problem was supposed to say you ask everyone who enters the cafeteria. So let's just make this everyone who enters the cafeteria. So, what kind of sampling would this be? It might be a convenience sample. The reason I might call it convenience is because it's not necessarily self-selected unless the members are volunteering. It's not systematic unless you've ordered the population in some way and you select from them in regular intervals, like every 10th person, every 5th person. And it's not necessarily a random sample because then you wouldn't be asking everyone. So we're going to go with this being a convenience sample. And it says, is this a good or poor way to conduct a sample? Well, if you're only sampling the people who are at the cafeteria when you're there, this is probably not a good method. A better method that might decrease the size in my choice of sampling might be the simple random sample. the way a random sample of the student population works is you would probably use a random number generator to pick a certain number of ID numbers. And so you don't know anything about these people. You don't know who they are. You don't know if they eat in the cafeteria or not. That's going to give you a better random sampling of the population. So maybe you would, use ID numbers to identify students. And that would be a better way to sample your population. Now I want you to notice here I didn't write incomplete sentences, and I probably should have, because on the test I need you to write incomplete sentences to accurately get your thoughts clear to me. The last problems, number 20, a calculator readout for a normal distribution gives x bar to be 50.2. Remember, x bar is the mean. Sx equals 5. The person who wrote this review also teaches the statistics class, and apparently they don't use sigma. Although if you ever look at the difference between sigma and Sx in the one variable statistics, you'll notice that they're very close to each other. Sx is going to be our standard deviation. It's our sigma. The minimum of this distribution is 35, quartile 1 is at 47.6, the median is 50, quartile 3 is 53.1, and the maximum is 100. Draw a normal distribution curve with values as many as 3 standard deviations away, and a box plot based on the numbers above. Let's start with the box plot. So I want you to look that the minimum is 35 and the maximum is 100. So maybe I'll make my box plot go from 30 to 100 in intervals of 10. So 30, 40, 50, 60, 70, 80, 90, 100. I'm going to start putting my dots on here. When we make our box plot, I'm going to put a dot at the minimum, a dot at the maximum, a dot at quartile 1, so 47.6 is probably about here. The median is 50, which is right next to it, and quartile 3 is 53.1, which is here. So little boxes very close to each other. For the normal distribution curve, there's my curve. My mean here is at 50, and if the standard deviation is 5, then my standard the standard deviations away from the mean are going to be at 55, 60, and 65. And on the other side, it's going to be at 45. Oops, I picked the wrong number, didn't I? Oh no, wait a second. No, I did. I'm good. Oh, I did. Darn it. As you see, I often make mistakes. The mean, which is not the same thing as the median, is at 50.2 if I look back at the data correctly. Now I'm going to go back again and do my standard deviations, which are going to be at 55.2, 60.2, and 65.2. Sorry, I'm running out of space here. On the other side, it's going to be at 45.2, 40.2, and 35.2. So that's my normal curve with 3 standard deviations away from the mean. We're going to use this information to answer some of the following questions. The first one is, what is the 25th percentile of the data? When you're making the box plot, where you've got your min, max, median, quartile 3, and quartile 1. Oh boy, it doesn't look very good. So the box plot has 4 dots to the right of the minimum. This one is at the 25th percentile, quartile 1. The median is at the 50th percentile. Quartile 3 is at the 75th percentile. And obviously the maximum's at your 100th percentile because that's at the end of your data. And the percentile is how much data is below it. So if I ask you what the 25th percentile is, I'm asking you for quartile 1, which is 47.6. But in C, when we want to find the 84th percentile of the data, you can't use the box plot to help you with that. In this case, we need the normal distribution curve, where we're going to call, or sorry, we're not going to call, but we're going to label the percents. 34 and 34, 13.5, 13.5, 2.35, 2.35, and 0.15, 0.15, which is over there. Sorry, it's kind of squished in the end and it doesn't even look like a 15. All right, in order to find the 84th percentile, one of the things I want to remind you is that on each side of the mean is 50% of the data. I claim if you add these numbers up, you're going to be at 50. So if I'm at 50, and I'll do this, and I take this another standard deviation over, 50 plus 34 is 84. Look, I'm at 84% of the data. What number is at 84% of the data? 55.2. And then there's a part D that says, are there any outliers explain, it says. Well, we will explain this. Sorry, I think this is funny because the person who typed it up didn't do spell check. All right, are there any outliers in the data? Look back at the box plot. Do you notice something that's way, way far away from everything else? Well, I hope so. It's 100. 100 is super far away from quartile 3. I mean, it's almost 50% of the way away. It's because quartile 3 is at 53.1 and the maximum is at 100. That's a difference of what, 46.8? All the rest of the data I have are not that far away from each other. So 100 is an outlier. Because it is, what did I say it was? 46.9 away from quartile 3. And again, none of the rest of the data were that far away. That is the end of the review for the Unit 4 test on statistics.